All right, so the last section we'll look at is 4.3. And basically what we're going to do is solve equations, mostly equations. The last problem, we'll do an inequality. And all the equations that we have, we're going to solve them algebraically. Okay, when we get to an inequality, we'll do two approaches. If it's a simple enough problem and we can factor it, then we can solve it with algebra. But if it becomes too complicated, we're going to have to use the graphing calculator. Okay, so the very last problem, we'll use the calculator. Right, and all the problems that we solve are all going to have rational expressions. Okay, so what that means is we're going to look at problems like that. Let's see, like that. Okay, all of the problems we solve have variables and they have fractions. All right, so one of the problems that we're going to do involves distance, rate, and time. So we need to know that formula. It's pretty basic, but I just want to make sure people remember it. Does anybody remember the formula? It has a R, a T, and a D in it. What it is?
Something like distance is rate divided by time.
Not quite.
Or rate times time.
Times time. Yeah, your distance is your rate times your time. Okay, so for example, if you're driving 50 miles an hour and you drive for 2 hours, you'd go 100 miles. You multiply your rate times your time. An equation right now, and then we're going to use several things. All right, so this problem, you really don't need to copy the whole thing. You just need the numbers, okay, and what they mean. So Sue drove 30 miles. And after she drove 30 miles, several things. All right, so this problem, you really don't need to copy the whole thing. You just need the numbers, okay, and what they mean. So Sue drove 30 miles. And after she drove 30 miles, okay, she got on a train and then completed her trip on the train. So she's going somewhere and drove 30 miles to the train station and then got on the train. Her total distance is 120 miles. Okay, so she traveled 120 miles. We don't know how fast the train or the car is going. But what we do know is on average, the train is 20 miles per hour faster than the car. Okay, so the train is 20 miles per hour faster than the car. So what we're going to do is find an expression that will tell us the time it takes for her to complete the trip based on how fast she drives in the car. Okay, so we're going to find an algebraic expression. We'll call it t, because it'll represent the time. And our variable we're going to let be x. Okay, and x is going to represent the speed of the car. Okay, so any questions on the setup of the problem? Okay, what Sue's doing, kind of what's happening here. Okay, so now we're going to write our formula. Okay, first I'm just going to write it as kind of ideas. Okay, I don't want to actually get into equations and variables yet. I just want to kind of get the concept. So the time it's going to take for her to do the journey. How many parts are there to her journey? 2 parts, right? What's the first part? Okay, so the first part of her journey is in the car. Okay, so to find the total time of her trip, we're going to have to take the time she spent in the car. And then what? Would we add something to it, subtract, multiply, divide? So we're trying to find, this is the total time.
So you'll add the time that was on the train.
Right, we have to take the time that she's in the car plus the time on train. That's basically our formula. Now we need to figure out using the numbers in the problem, what's the time in the car? What's the time on the train? All right, so how do you calculate time if you know distance and you know rate? Yep, Hannah?
You do 120 equals 20 times t, and then you divide by 20.
Yeah, so even without the numbers for a second, in general, if you just want to find time, take distance and divide by speed. Okay, so distance divided by rate, I'm going to put that over here. That's your time. And now, can you tell me again, Hannah, what was her distance in the car?
120. And the cost?
Just the car, yeah.
Okay. So.
Yep. So she had 30 miles in the car. And how about, John, what's her speed in the car?
We don't know that.
We don't know a number, but they did tell us how to represent it.
X?
Yeah. Okay. X is the speed of the car. So that's all we get. Okay. Now we're going to find the time on the train by taking the distance she traveled by the train divided by the speed of the train. Now they didn't give us the distance on the train, but I think we can figure it out. What was her distance on the train? Had to be 90 miles, right? She drove 30 in the car. The total trip is 120. So she must have gone 90 miles by train. And what's the speed of the train?
It's 20 miles faster than the car.
20 miles per hour faster. So x plus 20. Or I heard someone say 20 plus x. Same thing. Okay, so there's a formula that will give us the time it takes to do the trip. You just got to tell me how fast she drives in the car, and I can plug it in for x. Or I could look at it from a different angle. You could say Sue only has 3 hours to make her trip. How fast does she have to drive in the car to make sure she gets there in 3 hours? Okay. Okay, any questions on that equation? All right. So now I want to take this equation and analyze it just like we always do. Okay, let's find some asymptotes, the roots, and behavior model, and then we'll find a complete graph, which means do it on the calculator. All right. Now, when we work with rational expressions, do we usually have two separate fractions, or do we usually have one fraction all combined together? Yeah, we usually have one fraction, okay, like in the homework problems. Okay, they're usually like this. One numerator, one denominator. So the first thing I'm going to do is I'm going to combine these into one fraction. Sometimes it is helpful to have them as two separate ones, but for some other things it is helpful to have it as one big fraction. So to put them together, what do you need when you add two fractions?
Common denominator.
Yep, you need a common denominator. Okay, what would be the common denominator here? X would be part of it, times something else. Yep?
20.
So x times 20?
Or you would multiply 30 over x by 20.
Not quite. Not quite. So what's, like if you had, like, say, 3/4 plus, I don't know, 5/3. What's the common denominator there?
It'd be, it'd be x squared.
12.
plus 20.
Right? So all you have to do is take the two that you have and multiply them together. And that's one way to get a common denominator. That's how we'll do it here. So my first denominator is x. My second one is x plus 20. And you don't even have to multiply it out. Just leave it like this. That's the common denominator. Okay, any questions on that? Now, look at the fraction on the left. What is this denominator missing to have the common denominator?
20.
It's missing
Plus 20. X plus
more than just a plus 20. Yeah? It's missing the x plus 20. So what I'd have to do is multiply top and bottom by x plus 20. Okay, and I'll come back and do this in a second. Now look at the other denominator. What's this denominator missing? Just the x. So I'd have to multiply by x and by x. Okay, and that's how we combine them together. Okay, so when I do that, the 30 times x plus 20, that's a distributive. What's 30 times x?
30x.
And then I'm also going to have 90 times x, which is 90x. What's 30x plus 90x? So we can do that all together. And what's 30 times 20?
600.
600. Okay? So depending on what we need to do, maybe we'll go back and look at the original, or maybe for some of the things they want us to find, we'll look at the new one. Okay? But these are the same thing. I think this one is easier for me to type into a calculator because I can just put one big numerator and one big denominator. Okay. I'm going to need more parentheses if I try to do it the top way. All right, so they want asymptotes. All right, so let's start with our vertical asymptotes. Two numbers would make the denominator equal to 0. What's one of the numbers that would make it 0?
0.
0. And the other one?
20. Negative 20.
Negative 20. Now, I'm not saying these numbers make sense in the context of the problem, because x is the speed of the car. So maybe it doesn't make sense, but they wanted us to find it, so we found it. So that's vertical asymptotes. Let's do the EBM, because then that'll give me a horizontal asymptote. What's the highest degree term in the top? 120x. You might have not seen it was 120x if you wrote it as two separate fractions, but now you can because it's all combined together. That's why I did that. And be careful here. What would be the highest degree term in the bottom?
X.
Nope, not x plus 20. The highest degree term is not written right now. It would be x squared. Okay, if you did it out, it's x squared plus 20x. Okay, so you got to keep that in mind. Okay, and what does that reduce to?
120 over X.
Yep, 120 over x. That's my EBM. Now let x get really, really big in that fraction, and that tells you your horizontal asymptote. Okay, what happens to this fraction as x gets really big? It approaches what number?
0.
It approaches 0. Right? If x is 1,000,000, you have 120 divided by 1,000,000. Very, very small number. And when we write it, since it's horizontal, is that an x equals or a y equals?
X.
Y equals. Okay, I am going to put a question like that on the test where I have you pick. I'll put x equals 0 as a choice and y equals 0. Okay. Make sure you know horizontal is y equals. So we got the asymptotes. Find the zeros. Okay, so to find the zeros, that's where you set the equation equal to 0 and solve it. Okay, basically find this means find the roots. Find where it crosses the x-axis. All right, so if I set this equal to 0, what's the only way that that fraction could equal 0? Yeah, if the top is 0. So set the top equal to 0, and that's your roots.
-5.
Yep, it's going to be -5. So if I set the top equal to 0, I bring the 600 to the other side, and then divide by 120. And I get what Aiden just said, which is Negative 5. Adrian, sorry. Okay, that's everything they want algebraically. Now we'll graph it. Okay, I'm going to type in the one that we combined because I think it's going to be a little easier. So I've got 120x plus 600 divided by x times x plus 20. Okay, and if you put parentheses around it, the calculator will know that it's a distributive property, and it'll handle that fine. All right, so what would make sense for a minimum value for x? That's the speed of the car.
0.
Yeah, that's the slowest it could go, is 0. And how long would the trip take if she drove 0 miles an hour?
0.
It'd take no, it wouldn't take 0. That's if she drove like infinitely fast. But if she didn't drive at all, it's going to take forever. That's why all of a sudden you're going to see the graph go way up at a vertical asymptote.
Good one, John.
0.
Okay, maximum speed, let's just, depending on what the question asks, we don't know. But let's say she drives up to 70.
I don't know what car.
How about minimum for the time?
You can't go backwards in time, so
0?
unless you're Marty McFly.
Right. And this is time in hours. So she's only going 120 miles, so I'm guessing it's really not going to take that long unless she's going very slow. Okay, so we'll just say 3 hours to go 120 miles. Okay, so if we graph it, and let's see. Well, let me set that a little higher, because if I don't set it higher, you won't see the asymptote. You just kind of saw part of the graph. Okay, now you can see the asymptote. It's like going way up. Okay, so the slower she drives, the longer it's going to take her. Okay, as she starts to drive faster, the time decreases. But notice after a certain point, driving faster doesn't lower her time that much, really, okay, because it's starting to level off. Driving faster for lower speeds makes a big difference, but it doesn't make a bigger difference for higher speeds. Okay. Okay, so there's my complete graph. In the homework, to find a complete graph, just write down your mins and maxes. Okay, questions on that?
How did you find the zeros again?
Find the zeros, just set the equation equal to 0 and solve.
Okay.
Yep, same as finding your x-intercepts. All right, so now, second example, we're going to use the problem we just did. She's got 2 hours to complete her trip. Find the speed she should travel by car algebraically, and then we can also use our graph, not by hand, but on the calculator. All right. So, if she has 2 hours to complete her trip, where would I plug in 2? Would that get plugged in for t of x or for x? T of x, that's the time. Okay, so plug in a 2 equals, and let's use the equation we combined together, because if we use the top one, that would be the first step anyway. Combine it all together. And you know what else I'm going to do? I'm going to multiply out what's in the bottom. X squared plus 20x. All right, now my first step to solve that is I want to get the denominator on the other side, so I don't have a fraction. Okay, how would I move the denominator to the other side?
Times.
Multiply it. And be careful, because when you multiply each side by x squared plus 20x, it's a distributive property with the 2. Okay, and when you do it on the right, The denominator is gone. Okay, next step, what would I do with the 2? Yeah, I'm going to distribute it. So I get 2x squared plus 40x. And we can see the highest exponent is a 2. What kind of equation is that? It's quadratic. And when we solve a quadratic, we always want to get it equal to what number? 0. So I'm going to bring the 120x to the other side and the 600. Okay, we got some like terms we could combine, and you could have done this in the last step, but I'll do it right now. What's 40x minus 120x?
80x or negative.
Negative 80x. Now the next step is really just to make the numbers smaller. You don't have to do what I'm about to do, but everything here is divisible by a number, and if I do that, it just makes everything smaller. So what's everything divisible by? 2. So we can write x squared minus 40x minus 300 equals 0. Okay, and you can try to factor that, but it won't work. So what would be your only other option if you can't factor it? Quadratic formula. Now, I already have the answers when you do the quadratic formula. Does anybody want me to go through how to get the answers with quadratic formula? Or are we okay plugging in those numbers and solving it? Everyone's okay with quadratic formula? Okay, so the 2 answers you're going to get are x equals, it's going to be 20 plus or minus, just like always. (10√7). Now, when you solve with the quadratic formula, you always get 2 answers. But she's driving somewhere, so there's only one speed she can drive at. It's not like she could drive at this speed or this speed and get there in the same amount of time. That doesn't make sense. So how do you think I could eliminate an answer here? There's one answer there that shouldn't be there in the context of the word problem. Yep?
Can't drive negative.
Right, one of those answers is going to come out negative. Okay? If you find 10 square roots of 7, you can see it's 26 point something. So can you do 20 minus 26 and have that be a speed in this problem? No.
Well, she's driving backwards.
It's true, it's a different direction, but it's still positive speed.
Well, we're talking about like how long it would take for her to get to her destination, right? If she's backwards, it would just take longer to get to her destination.
Because she's going to go around the world, right? And come back the other way. So that's her speed. 20, and I'm just going to round it off. About 46.46.
That'd be impressive. I'd give her props.
What's that?
I'd give her props.
Yeah. So any questions on that? So that's the algebraic. Basically, it just comes down to quadratic formula. Now, how could I do it even faster with my graph? I have to add something to this picture first.
Yeah.
Not an asymptote. I need to add a line somewhere. Where would I add a line? Because remember, this is a graph of the time it takes. So I want to know how fast she has to drive if it takes her how long? 2 hours. So what would I do? Yeah, put a line at 2, and then you can see exactly how long it would take by doing second calc what? Intersect. So calculate the intersect. Does the guess, does it matter here?
Not in this case. needs to be the only answer.
Right, they're only going to cross in one spot, so the guess doesn't matter. And we get 46.46. Okay, so that's a very quick, simple way to check your answer. If the problem asks you to solve it, it doesn't say to use algebra or use a graph, you can do it either way. But if it says to use algebra or it asks for an exact answer, you're not going to get an exact answer with a graph. Only with the quadratic formula. Okay. So any questions on that one? All right, so notice what happened there. We got this second answer that didn't really make sense in our problem. Okay, and the reason why we got that is because we multiplied both sides by a variable. Okay, that was our very first step. We multiplied both sides by x squared plus 20x. Okay? It's okay to do that. You can multiply both sides by a variable, but when you do that, what you can cause to happen is you can create kind of this extra answer that shouldn't be there. Right? And that's what we did in this problem. We got this extra answer that was a negative speed, and it didn't make sense. So we have to rule out the answer that doesn't make sense. Okay. Does anybody know what you call that? An answer to an algebra problem that you did everything right, but it doesn't make sense in the problem. Begins with an E. Yeah?
Extraneous.
Yeah, it's an extraneous solution. Okay, and I can show you, I'll just put it there. Where else do I have to put it? There and there. Now I want to get rid of the third fraction. But let's factor this first and watch what happens. What does x squared minus 4x plus 3 factor as?
X minus 1, x versus 3.
It does. It factors as x minus 1, x minus 3. And that's always going to happen on every problem that I give you. The last denominator is going to be the previous two multiplied together. So now, since this denominator is x minus 1, x minus 3, what would you need to put in the top to cancel it out? Nothing. It's already there from the other two. Okay? That will always happen. So any questions why x minus 1, x minus 3 cancels out this denominator? If that didn't happen, the problem would be a little more complicated. Okay, so cross out what cancels. X minus 1's gone. X minus 3's gone. And that whole denominator cancels that. Anything that's left is a distributive property, so just be careful with that. So we've got 2x times both of those. Austin, what's 2x times x?
2x. Oh, sorry, 2x squared.
2x squared. And how about John, what's 2x times negative 3?
Negative 6x.
Yep. Now the next one, nothing interesting is really going to happen because you're just distributing a 1. But what I want you to be careful of is this sign. That sign gets distributed with the 1. Okay? So these two things are together. So that means if this was a minus, you would be distributing a minus 1 to both of those. Okay, that's a mistake people usually make on the test. Okay, so circle that whole thing. That whole thing is distributed. Okay, so distribute your plus 1. And what's left on the right side? Just a 2. Every one of these problems comes down to a quadratic. Sometimes you can factor it. Sometimes you got to use the quadratic formula. Okay, again, what do I want to get everything equal to? I want to get everything equal to 0. So I've got 2x squared. What's negative 6x plus 1x? Negative 5x. And what's negative 1 minus 2? Negative 3. Okay, so now let's try to solve it. This one will factor. That's why I picked it. And I need two numbers that multiply to give me 2x squared.
2x and x.
Yep, we need a 2x and an x. Now my signs would be what?
They beat that, so plus and a minus.
Yep, I gotta have a plus and a minus. I'm gonna try it like that, in the order that Hannah just said, plus minus. And two numbers that multiply to give me 3. 3 and 1. And it does matter which one we put where. 1 where? 1 with the negative? I would try the 3. Just a suggestion. So now if you do it out, you're going to get 2 times negative 3 is negative 6, plus 1 is negative 5. Okay, so that factors. Now, what do you do with each of these factors?
Set them.
Yep. And solve. And these are the potential answers. We have to check if anything is extraneous. Okay. What's the answer to the first one?
Negative 1/2.
Negative 1/2. And what's the answer to the second one?
Positive 3.
Positive 3. So now I'm going to go back up and make sure neither one of those cause me to divide by 0. If they do, cross it out. Okay. Can I plug in negative 1/2?
Yep.
That's fine. Can I plug in 3? No. Okay, that would not work. So that is extraneous.
Where did the negative 5x come from?
What's that?
Where did the negative 5x come from?
Oh, we factored it. So if you multiply it out, 2 times negative 3 is negative 6, plus 1, there's your negative 5. If you just FOIL it out, you'll get that. All right, so on the test, there's 3 cases that can happen. You can get both answers work fine. One answer works, one answer doesn't. Or it's possible both answers don't work. So if you got this far, but you forgot to cross this out, I'd take 1 point off. Okay? So if it's extraneous, make sure you cross it out and write extraneous. Okay? Any questions on that one? All right, so there is one of these on the test. Exactly this type of problem. That's an algebraic and then graphing. I don't want to spend too much time on the graphing one. All right, let's try this one. Okay, since this is similar to what's on the test, I want to spend more time on this one. All right, so first thing I want to do is find what I would need to multiply everything by to cancel out my denominators. Does anybody see the entire thing you'd have to multiply the first, second, and third term by? Yep.
X and then x plus 2.
Yep. X plus 2. X plus 2. X plus 2. What's going to cancel in my first fraction? X. Second fraction? X plus 2. Third fraction?
Oh.
Can you be more specific?
You cancel the x and the x plus 2.
X squared.
Yeah.
Yeah, I know what you mean. Yeah, yep. So everything cancels out. Okay, the first one, that's a FOIL. Okay, you need to do the whole thing out. So x times x gives me x to the second. What's x times 2? Minus 3x. What's 2x minus 3x? And then lastly, negative 3 times positive 2. Negative 6. Okay, next I'm distributing all of that. So a plus 3 to x. No, just plus 3x, not much you can do there. And what's on the other side?
-6.
-6. Now, what's going to happen when I add 6 to the other side? Yeah, it's going to cancel out. That's 0. That's 0. So now that my constants could each of these factors. Yeah. And solve. And these are the potential answers. We have to check if anything is extraneous. Okay. What's the answer to the first one?
-1/2.
-1/2. And what's the answer to the second one?
+3.
+3. So now I'm going to go back up and make sure neither one of those cause me to divide by 0. If they do, cross it out. Okay. Can I plug in -1/2?
Yep.
That's fine. Can I plug in 3? No. Okay, that would not work. So that is extraneous.
Where did the -5x come from?
What's that?
Where did the -5x come from?
Oh, we factored it. So if you multiply it out, 2 times -3 is -6, plus 1, there's your -5. If you just FOIL it out, you'll get that. All right, so on the test, there's 3 cases that can happen. You can get both answers work fine, one answer works, one answer doesn't, or it's possible both answers don't work. So if you got this far, but you forgot to cross this out, I'd take 1 point off. Okay? So if it's extraneous, make sure you cross it out and write extraneous. Okay? Yeah, any questions on that one? All right, so there is one of these on the test. Exactly this type of problem. That's an algebraic and then graphing. I don't want to spend too much time on the graphing one. All right, let's try this one. Okay, since this is similar to what's on the test, I want to spend more time on this one. All right, so first thing I want to do is find what I would need to multiply everything by to cancel out my denominators. Does anybody see the entire thing you'd have to multiply the first, second, and third term by? Yep.
X and then x plus 2.
Yep. X plus 2. X plus 2. X plus 2. What's going to cancel in my first fraction? X. Second fraction? X plus 2. Third fraction? Can you be more specific?
You cancel the x and the x plus 2.
X squared.
Yeah.
Yeah, I know what you mean. Yeah, yep. So everything cancels out. Okay, the first one, that's a FOIL. Okay, you need to do the whole thing out. So x times x gives me x to the second. What's x times 2? Minus 3x. What's 2x minus 3x? And then lastly, -3 times +2. -6. Okay, next I'm distributing all of that. So a +3 to x, just plus 3x, not much you can do there. And what's on the other side? -6. Now, what's going to happen when I add 6 to the other side? Yeah, it's going to cancel out. That's 0. That's 0. So now that my constant's gone, that means I don't have to use quadratic formula. I'm only going to have an x squared and an x term. So x squared plus 2x equals 0. And what do these both have in common? An x. Okay, what do you get if you factor out an x?
X plus 2.
X plus 2. So what are my two potential answers?
X equals 10.
X equals 0,
X equals -2.
x equals -2. Okay, let's go back up and check them. Can you plug 0 into the original problem? No. Can you plug -2 in? No. So this problem has no solution. Okay, both of these answers are extraneous. Okay, can't solve it. Okay. Any questions on that one? All right. So let's do this one. Okay, so this one is solved graphically, and we're going to do it on the calculator. All right, so there's a couple ways I can do this. One, I can do it the way it is. Type what's on the left in y1, type what's on the right in y2, and then see where y1 is greater than or equal to y2. What's another way you could do it? Kind of like the approach we just took with the quadratic equations.
Times of non-both sides.
Well, so it'd be nice if we could try to get rid of this denominator, but I can't multiply both sides by x minus 2. Why can't I do that with this symbol? I can do that with an equation, but I have to check for extraneous answers, but that's okay. But I can't do that with that symbol. Why not? What do you have to be careful about when you multiply both sides of an inequality by something? Something can happen. Ian, what can happen?
The inequality can flip
It can flip. When does it flip?
when you're multiplying by a negative.
When I'm multiplying by a negative. So if I multiply both sides of this by x minus 2, am I multiplying by a negative?
Yes.
Well, let's say x is 10. Am I multiplying both sides by a negative in that case?
No.
No. No, I changed my mind. Let's say x is 0.
So yes.
Now I am. So the problem is I don't know x. So therefore, I don't know if I multiply both sides by x minus 2. I have no idea if I should flip this or not. So that's why I can't multiply both sides by x minus 2. But another approach I could take is I could get everything on one side and get it greater than or equal to 0. Okay? And then I could calculate where is it above 0. Okay, I think the way I'm going to do it is just put what's on the left in y1 and put what's on the right in y2. Okay, so we got x to the 4th minus 3x cubed plus 2x squared plus 2. Okay, divide by x minus 2. Okay, and then just put 15 on, put 15 on y2. All right, so we're looking for where the graph in blue is going to be above the graph in red. Now, how come I can't see the graph in red? Yeah, it's at 15, and my y-max is only going to 10. So let's set it to 20. Just want to double check I typed it in right. Yeah. Okay, so there's the part you were seeing before. All right, and I want to know where we are above 15. Well, do I need to worry about anything in the bottom section in terms of being above the red line? No. I just have to worry about this top section. All right. Are there any values that you are not allowed to plug into this function? Yeah?
2.
Yeah, you can't plug in 2. Why not?
Make the bottom 0.
Great. We make the bottom 0. All right, so what I'm going to do is calculate and intersect. And I want the left one. Let's start with that one. So I can pick any value. There's my vertical asymptote. Any value from 2. Can I include 2 though?
No.
No. Any value from 2 up to 2.22. And I can include 2.22. Okay? If you pick any value between 2 and 2.22, it'll be above the red line. And I need to see where it crosses again. So that one is from 2.67, including it. And how high can I go for my x values from there? Infinity. I could just keep heading to the right, and this graph is always going to stay above the red line. Okay, so when you get a rational inequality, that's how you can solve it. Okay, there are some simpler ones you can do with algebra, but even the simple ones you can do with algebra, I'm just going to let you stick with this method. Okay, graph it, calculate some intersects, and then see, where you're above and below. Just make sure you're careful with values you can't use in the domain. Okay, so any questions on that? Right, so if you see a problem in the homework that says use a sign chart, okay, to solve the inequality, you don't have to use a sign chart. Just type what's on the left in y1, type what's on the right in y2, and just do what I did. Okay, ignore the directions in the book for that. Okay, so the homework, let's see, is 1 through, let's make it 1 through 11. Yes. Odd. This is one problem. 1 through 11 odd, and then, let's see, 20, that's good, 22, 24, 28, that's a problem traveling by train and car. 28 and 31. And you could also skip 22. Okay? So 1 through 11 odd, 20, 24, 28, and 31. So it's probably like 9 or 10 problem. Okay, don't forget, I'm here after school for extra help. If you have a test you need to finish, this is it for after school help. So otherwise, you've got to get it done during the day tomorrow.